Today we're going to look at our first section of Unit 5. This is section 5.1, Midsegment Theorem. Tomorrow we're going to deal more with the coordinate proof side of it. So first let's start by defining what a midsegment is. So a midsegment is a segment that connects the midpoints of two sides of a triangle. So the name is has the prefix mid in it, which sounds like midpoint, and segment, it is a segment. So if we look at the theorem involving midsegments, it says that the segment connecting the midpoints of the two sides of the triangle is parallel to the third side and half as long as that side. So if you look at your picture here, we have these markings showing that you have a single tick mark here, which means point D is the midpoint. Since we have double marks over here, that just tells you this side is a different length, but E is the midpoint. So therefore we know segment DE is the midsegment. The other thing to notice, it is parallel to the third side, and you're going to be able to calculate the length. So for example, if AC is equal to 10 units, the midsegment is half of that. So DE would be equal to 5 units. So we'll use those ideas to calculate pieces of this triangle. Okay, example 1, we're going to use the midsegment theorem to find some lengths. So in this diagram, we have segment ST and segment TU are midsegments. So when we are told that it's a midsegment, that means we can apply the theorem we just read about. So a couple things on midsegment. Let's mark its parallel. So we've got ST is going to be parallel to PR. And then UT, I'll put double parallel marks here, is parallel to PQ. The other thing is about the length comparison. So I'm trying to find the length of PR. So if I take a look, PR is right here. It is going to be compared to ST. So if I know that ST is 8, I can take 8 and double it to get myself to 16. So PR is going to be 16 units long. I'm also trying to find the length of TU. So if I find TU is this segment. I want to find the side it's parallel to. So PQ. These two have that half or doubling effect. So if PQ is equal to 10, I can take 10 and divide it by 2, and I get 5. So I know that TU is 5 feet. Okay, next example. In the diagram, XZ and ZY are midsegments of triangle LMN. Midsegments. So now I can apply my rules that we read about. And the measure of this angle is 40 degrees. We want to find several lengths. So let's put 40 on the picture. So YXZ is right here. We're going to put 40 degrees right there in that angle. So let's start with MN. So MN is this segment over here. So it is a midsegment, and it has a comparison with XZ. So this 26.5 is pointing to XZ. So if XZ is 26.5, I can take that number and double it. And so MN is going to end up being 53 centimeters. All right, let me take those segments off here. Oh, that's not what I wanted. Okay, let's just change colors. I'm trying to find ZY. Actually, let's just go ahead and erase here. So ZY is this segment right here. It is parallel to ML. They have that relationship. So if ML is 28, I can take 28, cut it in half, and that will give me ZY. So it turns out to be 14 centimeters. Okay. And then lastly, we'll deal with the angle. Let me add my 40 degrees back in here. So if I know that my 40 degrees is here, let's go ahead and remember that these two segments are parallel. So my 40 degrees and this angle have a relationship. If I have two parallel lines, this is my transversal, 40, and the angle I want, x, z, l, are alternate interiors. So the measure of angle x, z, l is also 40 degrees, and we're going to use our alternate interior angles theorem. So whenever we have parallel lines, we've got multiple transversals on here, we're going to be able to use some of that information. Okay, I'd like you to try number 3. I'd like you to pause this and read number 3 and try to apply this mid-segment theorem as you work to solve this out. Okay, in the example here, we have a triangle. We are told that these 3 points are the midpoints of the sides. So if D is a midpoint, I know that these 2 segments are congruent. If E is a midpoint, I know those segments are congruent. And if F is a midpoint, I have the same thing over here. So what that tells me is these segments on my picture are mid-segments. So EF is a mid-segment, DE, and so forth. So find the length of AB if we know that FE, so I'm going to draw on FE, is 6.5x minus 10, and AB, which is over here, is 3x plus 20. Okay, I have to apply my 1/2 or doubling rule. So there's 2 ways I could write this. I could say that the length of EF, which is the mid-segment, is going to be half the length of AB, or I know that AB can be found by doubling EF. Okay, so I'm going to take one of them and cut it in half, or the other and double it. So it doesn't matter which one you do. So I'm going to go with this second one. So I'm going to say that AB, well, let me plug in what AB is equal to. So AB is equal to 3x plus 20. It is equal to twice the length of EF. So 2 times 6.5x minus 10. Okay, so the setup is the biggest deal. Once you get your setup, then we can just solve through. So 3x plus 20 equals, let's distribute that in there. We're going to have 13x minus 20. Okay, and then I can take away 20 from both sides. At the same time, I can take away 13x. Okay, so then that gives me a negative 10x equals negative 40. And when I divide both sides, we end up with a 4. So back to the top, am I done? No, I'm finding the length of AB. So I'm going to have to substitute that back in there. So if AB is 3x plus 20, I'm going to have to plug in my 4 for x, and then that'll get me my length. So 12 and 20, so it looks like I get 32. So AB is 32 units. Okay. So those 3 examples really deal with mid-segment of a triangle, finding missing lengths, angles, and this was a little bit of algebra incorporated. The other part of this, let's set up coordinate proof, and then we'll look at coordinate proof a little bit more in the next section. Definition. Coordinate proof involves placing geometric figures in a coordinate plane. And what we're going to do with that is we're going to use lots of variables, and we're going to be determining lengths in terms of variables. So the idea behind this is getting much more comfortable with dealing with variables versus numbers. Okay, next 2 examples, we are going to place each figure in a coordinate plane in a way that's convenient for finding side lengths. Assign coordinates to each vertex. All right, so an isosceles triangle. Both of these we're going to draw our own xy axis. So start by drawing, we're going to draw just quadrant 1. Okay, there's my xy axis. If this is isosceles, it has 2 congruent sides. So I'm going to start by putting 1 point of my isosceles triangle at the origin. So this is 0, 0. I'm going to label this piece as M, and I'm going to label this as 2M. So if I'm making an isosceles triangle, Let's also label m up here too. And like I said, we're dealing with variables versus numbers. So let's draw our triangle. Let's put our second point at the top, our third point here, and let's connect and make our triangle. So if I've got length m and m, I'm going to have here two congruent sides. So this coordinate, I'm going to have to use variables. So on the x-axis, I've traveled m units to the right, and then I've gone up m units. So this ordered pair is m, comma, m. This coordinate right here on the x, I've traveled to the location of 2m, but I've not gone up or down, so that is going to be 2m kind of, comma, 0. So right now I want you to get used to seeing variables and coordinates instead of numbers. Okay, let's do the same for a square. Draw the first quadrant only, the x and y axis. So squares we know have 4 equal sides. So I'm going to put one mark here and one mark here, and let's just designate these are both length A. So A on the y-axis, A on the x. So my square will start here at the origin. I'm going to have A units going up in the corner and down here. So complete your square. And then we're going to assign coordinates. So if this ordered pair right here, I have not moved on the x-axis, I'm 0, comma, but I've traveled A units up. So 0, comma, A. On the x-axis, I have traveled A units to the right, but I haven't gone up or down, so that would be A, comma, 0. And then this ordered pair, I've gone A units on the x, and I've gone up A units, so we would call that A, comma, A. Okay, well, let's look at one more example. This one says we are going to place an isosceles right triangle in a coordinate plane, then find the length of the hypotenuse and the coordinates of its midpoint. So isosceles right triangle. So we're going to treat the origin as the right angle. So if it's isosceles, it has to be the same number of units on the y-axis as x. So let's put a tick mark here that looks like it's about the same distance, and we're going to call that length k. So we're going to assign k for each of these points. So my triangle will have a vertex at k on the y-axis and k on the x. So let's go ahead and draw that triangle. So here is the right angle, okay, and then this is isosceles. So this is the origin, 0, 0. Let's assign this ordered pair here. It's going to be 0, comma, k, because I have not traveled on the x but gone up to k. Over here, this is going to be k, comma, 0. Now, I want to go ahead and assign points for this triangle. So let's call this point P, and we'll call this one point Q, because I need to use that when I do my calculation. Okay, find the length of the hypotenuse. So PQ is the hypotenuse. So I need to find the length of that segment. So I need the distance formula. So my distance formula is x2 minus x1 squared plus y2 minus y1 squared. So I'm going to take my 0k and k0. So I'm just going to go ahead and call this one x1 and y1, x2 and y2. So when I run through my distance formula, I'm going to have k minus 0, that's x2 minus x1 squared, plus 0 minus k. Now you're going to have variables here, that's the whole point. So let's simplify. K minus 0 is just k. 0 minus k is negative k. Okay, and now if I square both, I end up with k squared plus k squared. So if I combine my terms, I'm going to have 2k squared. And I can simplify this radical a little bit. I can write this as the square root of 2 times the square root of k squared, and this is the one that can be simplified. So the square root of k squared is just k. So I'm going to be able to take the square root of k squared, but I'm left with square root of 2. So the length of PQ is this expression. The other part of this problem says find the coordinates of its midpoint M. Okay, so let's add M right here. We're going to call this the midpoint, which means P to M is the same length as M to Q. So when I find the midpoint of a segment, I use the midpoint formula. So to find the midpoint, we're going to use the midpoint formula. So the midpoint formula is to add the x's and divide by 2. So the formula itself was x1 plus x2 divided by 2, but it doesn't matter which x you start with. Y1 plus y2 divided by 2. Okay, so let's go back to our coordinates. So I have 0k and k0. So I'm going to have to add the two x coordinates, 0 plus k divided by 2. The two y coordinates, k plus 0 divided by 2. And then really all I can do, my midpoint is 0 plus k is just k. So k divided by 2 is the x coordinate. And I also have k divided by 2 is my y coordinate. So there's the midpoint. All right, so I want you to be comfortable with variables and follow through your formulas like you have done. So if you would take a moment, do your summary here, and then you can switch over and work on the assignment.